Children are highly inquisitive and are always asking questions. One of the most common questions that children have is, why is the sky blue? It's a simple and reasonable question, yet the answer is rather complicated, and most adults really aren't sure why the sky is blue. Learn why the sky is blue and how to answer a child's most common question on this episode of Everything Everywhere Daily. I want to tell you about a new podcast called Where There's a Will. Where There's a Will searches for the surprising places that the works of Shakespeare show up outside of the theater. Host Barry Edelstein, the artistic director at one of the country's leading Shakespeare theaters, asks what it is about Shakespeare that gives him a continuous afterlife in all sorts of unexpected ways. You'll hear Shakespeare doing rehabilitative work in a maximum security prison, helping kids on the autism spectrum to communicate, shaping religious observances, in the mouths of U.S. presidents, and even at the center of a deadly riot in New York City. Join Barry as he uncovers the ways Shakespeare endures in our modern society and what that says about us. Listen to Where There's a Will, Finding Shakespeare, wherever you get your podcasts. Once again, the name of the show is Where There's a Will. The fact that the sky is blue is one of the most fundamental and universal facts of the world we live in. If you wanted to use an example of something which is an obvious truth, you might say, the sky is blue. As simple and obvious a fact as it is, the reason why the sky is blue is a bit involved, and the truth is that no one really knew why the sky was blue until the 19th century. One of the explanations that people traditionally gave was that the sky was blue because it was displaying the reflected color of the water in the oceans. This, of course, makes absolutely no sense, as it's blue everywhere on Earth, even if there's no water to be found anywhere nearby. And on the same note, this is also the reason people gave as to why water was blue, because it reflected the color of the sky. The real reason why the sky is blue is a bit involved, but it's not hard to understand. But to understand it, you need to know a bit about the nature of light, our sun, the atmosphere, and even the human eye. Let's start with light. As you probably know, white light is made up of different colors. You might remember the mnemonic device to remember the colors Roy G. Biv, which are the first letters of red, orange, yellow, green, blue, indigo, and violet. Each of those colors have a different wavelength of light. Colors near the red end of the spectrum have a longer wavelength, and colors towards the blue end of the spectrum have a shorter wavelength. The entire spectrum of visible light lies in the range of wavelengths from about 700 to 400 nanometers. The next thing you need to know is about our atmosphere. By far, the two most common elements in our atmosphere are nitrogen and oxygen. Together, they constitute 99% of what we breathe. Both nitrogen and oxygen are usually found in the form of a molecule, where each nitrogen or oxygen atom is bound to another nitrogen or oxygen atom. Both molecules are very similar in size. An oxygen molecule is 292 picometers in diameter, and a nitrogen molecule is just slightly larger at 300 picometers. The next fact you need to know is how the light from the sun is distributed. The wavelengths of light emitted by the sun are spread over a much wider spectrum than just visible light, including the ultraviolet and infrared part of the spectrum. It's distributed in a bell-shaped curve, with the peak of the curve located around where green and blue light meet. So blue isn't necessarily the most dominant color emitted by the sun, but it is close. With all these basic facts about light, the atmosphere, and the sun, I can now put them all together. The first inkling that something in the atmosphere was causing blue light was discovered by the Irish physicist John Tyndall in 1869. He was conducting experiments with gases that replicated the atmosphere. He enclosed the gases in a long tube with a bright light at one end to replicate the sun. He would then introduce smoke into the tube and notice something peculiar. When he looked at the glass tube from the side, the light had a bluish tint. However, when he looked at the light from the opposite end of the tube, it had a reddish tint. Tyndall proposed that the particles of smoke were reflecting the blue light, and as such, the blue in the sky must be due to particulate matter in the air. Tyndall's explanation was wrong, but he was on the right track. The answer was to be found in Rayleigh scattering. Rayleigh scattering was discovered by the British physicist Lord Rayleigh. He was awarded the Nobel Prize in Physics in 1904 for his discovery of argon and his study of atmospheric gases. Lord Rayleigh determined that it wasn't particles in the atmosphere, but the atmosphere itself. He determined that something happened when certain light waves hit molecules that were much smaller than the wavelength of light. In particular, if the molecule size is near the wavelength's fourth negative power, you get Rayleigh scattering. The light will bounce in random directions. It just so happens that, given the size of oxygen and nitrogen molecules, the wavelengths of light which are scattered the most are the shorter wavelengths near the blue end of the spectrum. Indigo and violet are actually scattered slightly more than blue is. However, the sun produces much more blue light than it does indigo or violet. Technically, all visible light can be scattered, but about 20% of blue light is scattered versus only 5% of red light. So to summarize, the oxygen and nitrogen molecules that make up almost all of our atmosphere are tuned to scatter shorter wavelengths near the blue part of the spectrum. The reason why the sky is blue instead of indigo or violet is that the sun simply produces more blue light. There is also one other contributing factor as well: our eyes. The human eye is more sensitive to blue than it is to indigo or violet. We can see indigo and violet, but blue is much more pronounced. So that is why the sky is blue. It's a unique combination of our sun, atmosphere, and eyes. Now at this point, you might be saying, but Gary, the sky isn't always blue. At sunrise or sunset, the sky can be red, yellow, or orange. And that is correct. And the reason has once again to do with Rayleigh scattering. The amount of atmosphere between you and space is shortest when you go straight up. But when you look to the horizon, there's much more atmosphere that the light has to go through. There's so much more atmosphere that most of the short wavelength colors on the blue end of the spectrum are almost totally scattered, leaving only the colors of the longer wavelength part of the spectrum, i.e. red, yellow, and orange, to reach your eye. Although it's rare, it is possible for the sky to turn other colors. There is an old legend that the sky turns green before a tornado. While a green sky doesn't necessarily mean a tornado, it sometimes happens when there are storm clouds just before sunset. And before sunset just so happens to be the most common time when tornadoes occur. I've actually seen it myself several times, and it's really eerie. The reason for this is due to the blue part of the spectrum being scattered away just like you would normally see at sunset. However, the green part of the spectrum, which hasn't been scattered by the atmosphere, can now be scattered by water molecules. And because all the blue light has been scattered already, the clouds now appear green. Now, some of you might be wondering further, if the sky is blue on Earth, what color is the sky on another planet like Mars? The Martian atmosphere is very different than the Earth's. For starters, the pressure is less than 1% of ours, so there just isn't much of it. Second, the largest component of the Martian atmosphere is carbon dioxide at 95%. A carbon dioxide molecule is much smaller than a nitrogen or oxygen molecule at 232 picometers, so it's not going to scatter visible light quite as well. Much of the Martian sky's color comes from dust in the atmosphere. The iron-rich dust tends to absorb blue light, giving the sky what is often called a butterscotch color. However, that being said, rovers on Mars have detected a bluish halo around the sun near sunset or sunrise when atmospheric conditions are just right. So, what about some other planet? Could there be different colored skies on a planet around another star? And the answer is yes, it's entirely possible. Given a different atmosphere and a different light profile from a different star, you could get a different colored sky. Granted, we probably couldn't live on such a planet, but it would have a different color. So, the next time a child asks you why the sky is blue, just tell them that it's due to blue light waves bouncing off of molecules in the atmosphere. And if that doesn't satisfy them, just tell them to wait till they're older. Everything Everywhere Daily is an Airwave Media podcast. The executive producer is Darcy Adams. The associate producers are Thor, Thomsen, and Peter Bennett. I just wanted to extend a big thank you to everyone who is supporting the show over at patreon.com. I have show merchandise available there, including hoodies, t-shirts, and stickers. Plus, it really just helps me get this show out every single day, including, of course, weekends and holidays. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.